an assistant professor at Amat University, Chennai. Today in this session we are going to see the eigenvalues and eigenvectors. Eigenvalues and eigenvectors are very important in diagonalization of matrices and in the application of engineering mathematics. In eigenvalues, eigenvectors, we are going to see the diagonalization and orthogonal diagonalization of symmetric matrices and application of eigenvalues and eigenvectors. What are eigenvalues and eigenvectors? Suppose if we have an n cross n matrix. Matrix is just an arrangement of numbers, rectangular arrangement of numbers in rows and columns. So for a matrix n cross n matrix and a scalar lambda, a non-zero vector x is said to be an eigenvector, then it should satisfy the condition Ax is equals to lambda x. A is an n cross n matrix, lambda is a scalar, it can be 0 or anything. X is a non-zero vector. Geometrically, what is eigenvalue and eigenvector representing? Eigenvalue is nothing but we are taking a scalar from a field, and eigenvector is we are trying to find a vector when we are hitting by a lambda such that it should not change the direction. Let's find the eigenvalues and eigenvectors in this example. Suppose if we have a matrix A equals to 2, 0, 0, minus 1. This is a 2 cross 2 matrix. The eigenvectors for this matrices are x1 is equals to 1, 0 and x2 is 0, 1. To check this, multiply that matrix A with the column vector x1. We will get 2 times x1. Similarly, multiply A with that column vector x2, we will get minus 1 times 0, 1. So the eigenvalues are 2 and minus 1 here. The eigenvectors are 1, 0 and 0, 1. Let's see the theorem. The eigenspace corresponding to lambda of matrix A. What is the eigenspace? For each eigenvalue, we can find the eigenvectors. The eigenvectors, the dimension of the eigenvectors form the vector space including the 0 vector. So the dimension of the eigenvectors are nothing but the number of non-zero vectors in that eigenspace. To check the subspace, we have to check the vector addition and the scalar multiplication. So to check the vector addition and scalar multiplications are inside that subspace, we have to check A times x1 plus x2 is equals to lambda times x1 plus x2. Similarly, A times cx will be lambda times cx. Let's find the eigenspace in this example. Consider the 2 cross 2 matrix A equals to minus 1, 0 and 0, 1. The first eigenvector will be the x-axis and the eigenvalue will be minus 1. Similarly, the second eigenvector will be the y-axis. The eigenvalue will be plus 1. This vector will be because this x comma 0 will be the subspace of R2. The subspace of R2 will be set of all lines which passes through the origin. So x-axis and y-axis, they are passing through the origin. So they are the subspace of the vector space R2. How can we find the eigenvalues and the eigenvectors if we are given with a matrix A equals to m n cross n? That n cross n mention the dimension of that matrix. When we are given with the matrix, we have to write it as Ax is equals to some lambda times x. X is some non-zero vector. We have to assume that. Then we have to find lambda I minus A is equals to 0. This will be the system of homogeneous equation. The system of homogeneous equation, when can we find the non-zero solution for the system of homogeneous equation? We have to find the determinant of that matrix and we should get the non-zero determinant. So we have to, non-zero determinants means the solution will be trivial. So we have to equate the determinant to 0. We will end up with nth degree polynomial. If we solve that polynomial, we will get n roots. That will be the n eigenvalues. The eigenvalue can be repeated or different. Next we will find how to find the eigenvectors, that we will see in the next session. Thank you.